Hello viewers, welcome to another section of my tutorials. And today I have a question in physics, which is a problem of Torricelli's principle and equation of continuity. So the question says an open tank of cross-sectional area A1 holds water 3.0 meter deep if a small hole of cross-sectional area A2, which is equal to 0.2 meters squared, is made at the bottom of the tank. Calculate the mass of water per second initially flowing out of the hole exposed to the atmosphere. You can assume that A2 is far less than A1. So how do you go by it? Let's draw a diagram for the question above. So we have an open tank, and let's say we have our tank, big tank, and here is the open end here where the area is A1, and instead we have a cross section, a small hole at the bottom. So let's make a small hole down here, and here will be our A2, and it's having a magnitude of 0.2 meters squared. So they are saying that this tank is holding a water of height 3.0 meters. So let's assume that this is a water height 3.0 meters, like this. So you know that if you're having a diagram like this, or if you're having a tank containing water at this height, water will be exuding from the bottom hole, and the question is asking us to find the mass of water per second that will be flowing out of this small tank here. So how do you go about this? So mass of water per second is what we call the mass flow rate. The mass flow rate. Now mass flow rate is also given by density times the volume flow rate. Now how do you get the volume flow rate? We all know that the volume of every shape or every object is equal to its cross-sectional area multiplying its height or length, let's say length, and all know that if you're having length from the velocity equation, velocity is equal to length over time. So if I make the length the subject, I'm going to get length to be equal to velocity times time. So putting it back to the volume equation, I'll get my volume to be equal to area times volume times time. So from here, dividing through by time, I'm going to get V on T to be equal to A times V. So therefore, the V over the T will be equal to A times V, and this is the volume flow rate. So for the volume flow rate, so from the mass flow rate, we can conclude our formula to be equal to the density times the area times the velocity. From the question, we know that we are dealing with water and the density of water is 1000 kilogram per meter cube. But out of the area, we are dealing with where the small parts, that is A2, it was given to be 0.2 meters squared. But what about the velocity? How do we get the velocity at which the water will be effluxing from this point? So from Torricelli principle, we know that velocity is equal to the square root of 2gh. Now, from here, we make our substitution, we get our velocity to be equal to the square root of 2 multiplying gravity 9.8 multiplying the height, which is 3.0 meters. So what do we get for this? If I punch into the calculator, I get square root of 2 times 9.8 times 3. I'm getting 7.67 meters per second. So getting my velocity, I put it back into the mass flow rate formula. So I get my density times area times velocity and this will be equal to the density of water, which is 1000, times the area of the small part, 0.2, times the velocity, 7.67. What do I get? 7.67 times 1000 times 0.2. So I'm getting 1534. And what would the unit be? He said mass flow rate, mass per second, so it will be kilogram per second. So this is the end of my video. Thank you for watching. Kindly subscribe, like if you found it very helpful. Thank you.